Good morning, students. Lesson will be a very short lesson on a topic which is called clippers and clampers. In fact, there are basically it is how to use a diode. By using a diode, you can always play around with a sinusoidal waveform, and I'll show you two, three examples, and uh, somewhere else in your textbook you can find many other examples, but if you ask me practically, there is uh, there is nothing much theory to be discussed on this. There can be textbooks where long stories are written about clippers clampers, but it's not necessary. You have to just, I'll show you, you will agree with me at the end. You have to just see and judge how the diode works, how the diode conducts. It is actually idea is to find out how a diode really works. Here you see a sinusoidal source. I have taken purposefully RMS value 7.07 volts so that peak to peak, zero to peak value 10 volt. That makes the measurements easy. I can show you that. I run this oscilloscope. You see, it is 10 volt. It is 5 volt per division here. It is 5 volt per division here. So 1 5 and 5 10, so peak to peak value 10 volt, right? Now look at this diode. This diode I connect here, just a diode and a bias, the small power supply. This power supply is supposed to be for 5 volt. Theoretically in your textbook you will find 5 volt, but in lab you will find 5 volt will not work, because this diode itself has a 0.6 volt potential difference. If we put 5 volt, then let us see what is the input and output. After observing input output, I'll explain how it really works. See, input was that red line which has been overlapped by the blue line. Blue line is the output here. What has happened so? It is simply because when the input goes above 5 volt, this diode is forward biased, diode conducts, and neglecting the diode resistance, the voltage here is just 4.4 volt plus diode barrier drop, total 5 volt. The output here is 5 volt. That means if you make this arrangement, output will be clipped to 5 volt. This is called positive clipping because positive side has been clipped, right? Let us take another example. This is whole idea is as simple as this. Another example. Let us take uh, let us take this diode where this bias is reverse. It is negative. You see negative in the upper side. Then it was positive and it was negative. Now let's see how it works. You see, the output does not go above minus 5 volt, because when the output is above minus 5, let us say output is 0, output is 0. If output is 0, then this negative bias, this diode starts conducting. So this is minus 5.6 volt, and from there you subtract 0.6 volt of this diode. So output is clipped to minus 5 volt. Similarly, you can make many other combinations. Suppose you add these two, both of them. Then how it works? Then it is also same thing. Then let us say you add, then let's say I add this one and this one. Then see, the output does not go above 5 volt or does not even go below 5 volt. If it is go above 5 volt due to this diode conducts. This above 5 volt output is clipped to 5 volt. If the output is below minus 5, that is say minus 6 volt, then this this diode is forward biased in upper direction and it also gets clipped to minus 5. So this is all I have to tell you uh, about bus, right? Nothing more than that. And uh, in your laboratory, or if you have a simulation program with you, you can make many arrangements and see how all this works. Then let us go to another idea, which is called clamper. Clamper will need a little description, explanation. I'll zoom it and show it to you. This is a clamper. Once again, these diodes. But once again, these diodes, and this is a resistor for taking the load output. And here, only additional thing is a capacitor. This capacitor. Once again, this is clipper. There was a resistor. In clamper, resistor is here, is a very high resistor, and there is a capacitor here. This is 500 nano, half microfarad. How to decide the value of this capacitor and resistor, I think you should. This is not actually a part of clipper clamper because you don't have to design clipper clamper. You have to make trial and error and find out. Now, here, let me connect this diode and see what is the waveform. Output waveform is this pink one, you know, and input waveform is this red one. So here you will find the input is average 0, right? But the input has a peak value of, this is 10 volt per division. This is 10 volt peak. 7.07 volt RMS means 10 volt peak. And oscilloscope channel is 10 volt per division. So red line, you can see this is 10 volt peak. So here you will find the output is a DC bias and gone above by 10 volt. That means the peak value of the input has become the average value of the output. This happened. It happened because in the very first negative cycle, when this bottom end of the circuit was positive, rather I should not use the word positive, bottom end potential was higher than the upper end potential. At that time, a current has flown in this direction. Let me see whether I can show you the very first, the very first cycle. The very first negative cycle of the input, see, look at the waveform here. The very first negative cycle of the input does the magic to this circuit. The current flows from here, and since it has a 10 volt negative, so this current flows from here through this capacitor in this direction, and the capacitor is maximum charged to 10 volt. Because this voltage here, see, it goes negative from 0 to maximum 10 volt, right? So this voltage goes from 0 to maximum 10 volt. So at that time, this capacitor is also charged to 0 to maximum 10 volt, right? So this capacitor has a charge of 10 volt. I shall put a text here. Since this becomes positive and other end becomes negative, right? So the capacitor is charged to 10 volt. Thereafter, when the signal goes to its positive cycle again, then what happens? Then this diode does not conduct, it is reverse biased, and this 10 volt charge of the capacitor tries to discharge through this resistor. But see, this resistor is very high, 1 megohm resistor. So even if it tries to discharge, it will not be, but even if it discharges, it will be a few millivolts only. So practically the capacitor will hold 10 volt, right? But then during this positive half cycle of the signal or the source, another 10 volt come here, right? So what is the total voltage of this capacitor now? The capacitor is now charged permanently to 10 volt. So if the capacitor is charged to 10 volt, for the cycles thereafter, capacitor holds a 10 volt charge and signal of plus minus 10 volt appears in addition to this plus 10 volt. So later on, in the after a few cycles, here the capacitor is holding a charge of 10 volt and the signal is riding over the 10 volt with a plus minus 10 volt, right? So this is how this clamper works. It is called that input signal is clamped to plus 10 volt. Let's make another trial where the diode is reverse biased. If we reverse bias is, then of course I can say if I take the reverse diode, the signal will be clamped to minus 10 volt. Let's see how it works. The signal is now clamped to minus 10 volt. So these are called clampers. That means with a single diode, you can shift the DC bias of a signal. But very truly speaking, want to shift the DC bias of a signal, then normally you don't use such clippers and clampers. There are special transistor-based circuits with which you do DC. These are actually originally long time back, these were discussed and maybe it is used in electrical engineering. But in electronics engineering, such easy clipper clampers are not used. You use transistor-based circuits. So this was all about clippers and clampers. And for the purpose of your exams, I think what you at the most you do, normally the questions I have seen they come that they give you a figure and give you the input waveform, this is the red waveform, and ask you to draw the output waveform. There is no mathematical calculation or theoretical discussion above. So you have to observe the circuit properly and decide what should be the output waveform, right? So that was all about clippers and clampers.